Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Resilient Analytics in Logistics, with special guest Adrian Kosowski, Chief Product Officer at Pathway. Adrian, welcome to the show.
It's a pleasure to be here, Darren.
So, Adrian, before we get into what Pathways is and all that, let's first tell my audience a little bit about yourself and then where you come from and why you're doing what you're doing.
My background is in distributed computing. So I actually went through a research career, largely in France, with some of the leading engineering schools and institutes in École Polytechnique, studying different aspects of distributed systems and optimization in distributed systems. I did a mix of distributed computing and understanding how computations scale and looking at how real-world systems can be modeled from a distributed computing perspective. So there are a lot of systems in the real world, which include everything from transportation to actual social interactions between animals and others that can be modeled with a distributed computing perspective.
Oh, very cool.
So I had this like double approach to it, and I belong to the distributed computing community. It's a research community that studies how to make sure local algorithms can be proved useful for computations and for understanding systems. And this is a bit of my my DNA, and it somehow naturally led us when we were creating Pathway to study systems which can be modeled, understood from the same local perspective of local interactions, local changes in systems.
So I really like your approach because I'm a systems guy too. I like to look at things at a systems level and go down. So how does the real world interact? Can I model that? Can I improve it through distributed systems? I love it. So I mean, this is awesome. I get to talk to someone that understands me, which is great for me. So when you started looking at this, what was some of the biggest challenges you ran into with the current way that the industry is tackling this problem of mirroring or optimizing current systems, distributed system, real world type things like logistics or, like you said, social interaction, things like that. So what was the biggest challenges you found in doing that?
So when we started out with data in the logistics and transportation vertical. A lot of the data was beginning to come from IoT sources, automatically collected traces of how objects move around. And this is very interesting data because on the one hand, it's extremely simple to describe what's going on in this data. You just have some traces like a timestamp, GPS location, latitude, longitude. So there's not so much to it, perhaps some event that is associated with this data. But on the other hand, aggregating this data at scale and making sense of what's going on across multiple devices is a major challenge. So we found ourselves on the intersection of working with real-time data coming in from the edge and the necessity to make sense of it, to structure it, to do logical conclusions, which belong to the realm of some kind of machine learning analytics. So this was the major challenge, that somehow we found ourselves in between advanced analytics capabilities that were required of these systems to deliver value, and a streaming approach, an event-driven approach to sourcing data, and we needed to put the two together.
Right. Well, and this is a big problem that a lot of people actually have. Right. How do I run deep analytics on streaming data? And like you said, AI has now grown up enough where we can probably leverage some AI. But right, I mean,
It is the time for AI, and it is
yeah,
the
it
time
is. I
for
mean, yeah, we could have Chat GPT solve all the world's problems according to some people, but, but not logistics problems.
it's true that a lot of progress in AI is I wouldn't like to say consumer facing, but it's very much about increasing productivity of people, and the part of analytics that we took on was really much closer to bringing value insight out of data sources. So it's more on the enterprise analytical backbone side of things.
Which I think is more important, frankly, because we're talking big systems. So small changes can make big impact into industries, not just individual companies, but industries, especially with logistics, because you're actually dealing with several different companies at the same time with logistics, right?
Indeed, indeed. And logistics is a fascinating area just because of what you said, that the market is so concentrated that just making a small improvement in one single process makes an enormous difference for, well, the world economy, actually. Because if you think about it, uh, transportation is something like 10% of overall industry production of GDP. And then
Oh.
if you look at it, like world trade is highly concentrated. Most of the value of goods that are being shipped is linked to containerized shipping. And this is controlled by a handful of companies. Five major players on the maritime side control half of the market in terms of like freight forwarders and outsourced logistics processes. This is also a highly concentrated market. So these are enormous processes which span millions of containers, each of which having value of merchandise transported in the tens of thousands of dollars, sometimes much more. And all of this is like one data source, which is maybe not even completely enormous in terms of data size. And any kind of like tuning analytics improvement on top of this allows to do value all across the operations that are concerned.
Now, what are some of the issues that you run into when collecting data from the edge, um, especially logistics data? Because you said the data is pretty simple, right?
Mm.
Right, latitude, longitude, a timestamp, maybe a little bit more data on what you're tracking. But what are some of the challenges with distribute with gathering this data from, I would call it the extreme edge, because some of these containers out in the middle of the ocean, right? That's an extreme edge case, right?
So the situation is in some sense optimistic in that the catalog of problems is rather limited. It seems that the problems that appear are pretty consistent across different types of IoT devices involved and different types of collection. There are generally speaking, issues associated with the devices as such, with the sensors that are responsible for measurement, and there are issues related to communication. Both types of issues appear. Um, Interestingly enough, the, mm, there's a lot of um, misconceptions about what these devices, these edge devices, are actually capable of, and how they can be expected to perform. It's if we think of logistics processes, you may have a container that's traveling for weeks without a power source. So you have a battery-powered IoT device which needs to optimize energy clearly, and apart from the fact that energy is an issue, which means that communication is an issue, you have to optimize
Yeah.
bits of communication. You also have the issue of basically, I don't know how to put it, like stability and reliability of these edge devices. If a device fails or crashes, this is a major issue, which means that you should have a way of optimizing these what these devices do without them crashing or performing incorrectly or getting jammed or stuck. So there's like one major source of issues is that trying to make smart devices that do measurements in a smart way adaptively, or that do communication in a smart way, also means that these devices may malfunction or not follow specification or just get stuck in off state with no way of reaching them. So this is like one category of issues which vary widely according to manufacturer of device. So it's actually possible to benchmark these devices and see that theoretically similar devices have very different profiles in terms of the errors that they're generating. There are issues related to the fact that we're talking about the extreme edge, and it's devices that lose connectivity regularly, that they will need to catch up at some point and communicate late data points to let's say the cloud in inverted commas to the centralized data collection. And this is a major issue, especially if you think from a streaming perspective, because streaming systems are traditionally not so used to handling out of order
Out of order data. Yeah, that's
data.
an issue.
Yeah. So it's this, and then by now we've learned to recognize the typical patterns of errors that we see with GPS issues, with positioning issues. These are quite fascinating, actually, and many of them are related to kind of like, I wouldn't like to say cover-ups, but they are indeed cover-ups of a device that wasn't really measuring, but was communicating some data anyway based on some extrapolation of what it thought was right, and there's no way to to cleanly distinguish what's an actual measurement and what's a guess by the device. So it's it's kind of
So it's a lot. It's interesting because I would have thought that the data would be a lot cleaner. It sounds like the data is noisy, can come out of order, and for like you said, for real time systems, they're used to events coming in order, right? So this is a pretty because of the not the data itself, but the way that the data is collected and where it's being generated, it ends up being pretty complex.
It does indeed. It does indeed, and there are some issues that we see no way of resolving that are inherent to the data, and this out of order arrival is one example. There are some issues that require contextual data analysis, which means that interpreting the meaning of a given data point and learning to distinguish issues with the measurement from issues with the actual process that's being traced very much depends on the context where this measurement was made, what were the precedent measurements, what other devices measured in a similar location. So one example is, let's say, temperature measurements. If we are thinking about sensitive shipments where temperatures need to be kept below a certain threshold, it's absolutely normal that only the part of shipment which is actually sensitive has this temperature controlled, whereas the device, the measurement device, is associated with a box. And in some cases, it's perfectly normal that the temperature of the box will go up when refrigeration is no longer needed, for example. So there's no need to raise an alarm. And the kind of issues with today's supply chains is that all of this has to be to some extent inferred. There's no super precise information which would tell the unfortunate IoT device if the cargo has been loaded inside the box which contains the IoT device or not. All of this is a little bit requires a little bit of heuristic inference.
Fascinating stuff. So, um, what are the what are the effects of not having accurate data, and in timely accurate data? Because you said there's lots of different things, right? I've got some data that's inferred, some real data, some not. Things coming. So, what's the effect on the logistics chain by? Because I guess I shouldn't say our supply chain is great, even though it's actually pretty good when you think the worldwide supply chain. It's been pretty robust for several years. I mean, COVID kind of threw a kink in some of that, right? But what's the effects of having this data that's not necessarily accurate to the industry today?
So if we look at supply chains specifically, the current state of the use of the data is that it's still not widely used in aggregation. That is, if you think of a given shipment, a given piece of cargo as being important, you taste it, and the conclusions that concern this given shipment are obtained from the data which it collects. There's very little in terms of systems that are able to aggregate data across multiple devices to do conclusions that allow to optimize, for example, transportation networks, that allow to minimize risks to transport or to actually to find these risks out in advance. Indeed, the one thing that COVID forced us to think about was really moving to a new normal, that supply chains reorganized in a completely different way, and based on relatively small amounts, small data samples, there was a need to figure out the new processes and to understand whether these new processes make sense without being able to rely on the aggregated experience of humans who'd been experts in the field for tens of years.
Well,
And,
yeah, you've got all that. This is really interesting because it's not just tribal knowledge inside one organization, it's tribal knowledge across an aggregate of companies. Because, like we said, in logistics, there is this knowledge that's kind of gained across several verticals and across several organizations on how everything works. I, right? I mean, is there anyone out there that can draw a picture of our global supply chain of accurately?
it's super difficult, and actually one of the main changes, of the main potentials for change that we're observing with the existence of IoT like data sources and the massive rollout of IoT is that this visibility and this observability of what's going on becomes end-to-end, which means that we actually start to have data which is not partitioned by what's known or visible to a given subcontractor or a given link in the supply chain, but we have like a global view of processes, which is quite fascinating from the point of view of analytics capacity it unlocks and the potential for improvement for different actors. So in some cases, this potential means that there's something that's really actionable, like I can improve a process. In some cases, it's actionable because it provides information about what to expect. We can expect congestion, we can expect damage in the next few days, and gives the time to prepare and to adapt other processes potentially downstream in the supply chain or related to retail when waiting for supply to be able to cushion potential blows before they actually come, to be proactive.
So when you guys are attacking a market like this, where there's several different organizations, is there one that you're really going after to say if we can get them to adopt new techniques of gathering data and ingesting and curating data and building insight from that, that will give such an impact into the global supply chain? Is there a group or a segment that you guys are focusing on where you think that'll be the biggest impact?
I'd say that there's a big will of actors to collaborate in terms of putting into place new methods of treating data. While of course this is a kind of competitive advantage, and whoever adopts it first. It traditionally was not the main angle, the main type of differentiation between companies that do actual operations in the physical world. So there's some will to cooperate and to catch up and to adopt new approaches all across the board. Basically, if one major actor adopts something across their operations, some kind of
Everyone
solution,
else
then
does
everyone
too.
else does. So this is
So
true.
it's a weird. So it's almost like a competitive collaboration to kind of lift the whole industry as a whole. Is that
It's this, and it's also a question of finding shortcuts to making an organization data driven, because there's some organizations, I should name Amazon here obviously, but Alibaba as well, and others that have that actually no longer moonlighting as data providers. They are data centric organizations in all the aspects, and these organizations have data at their heart, and it's kind of more obvious for them to work with data. There are other organizations for which it is less obvious, and that are very much looking for shortcuts to get the similar level of value from their data, and to actually lead or compete on equal terms.
that's really interesting. So Alibaba and Amazon are kind of pushing the industry as a whole because they are data driven, they are data centric. So the others have to follow where they die,
It's
right?
it it is I guess it is the case that actors who don't have this data DNA run the risk of commoditization, in the sense that they become something like physical subcontractors who just operate certain operations but lose the link with clients and with the actual management of processes.
All right, so let's shift gears a little bit and talk about pathway, right? Because your background's incredible. You understand the space really well. So why develop pathway? Because there's other data streaming technologies out there, open source. We could talk about Kafka, we can talk about Flink, we can talk about Spark that do data analytics on big data analytics, right? So why do something different? Why? I mean, what makes you guys so unique? Besides Adrian, obviously, besides your knowledge of distributed systems, I mean, but why do something different?
Indeed, we were when doing pathway, when we got to the place when we did pathway, we did it for the reason that we were missing a tool, and we felt that we were missing a tool that would resolve what we needed to do, and we needed to develop advanced analytics pipelines on top of data streams, notably data streams that were coming from IoT, but in general event streams data. We found that the existing frameworks were deficient for multiple reasons. That what we were looking for was a certain ease of describing logic as if it were meant for a batch system, and making sure it works in a real-time system with out-of-order data, that it relieves whoever's designing the system of this need to care about manual event processing, while under the hood being an event processing system. So
It's a strange place to be in. I mean, anytime anyone thinks about getting delayed events, the first thing that comes to my mind is, oh, you got to batch this stuff up. It's got to be batched, and then so you're spanning the space between batch and real time systems with constant continuity of events and things like that, right? So you're spanning this really nebulous space in between which the real world works in, right? Instead of the computer world, right? The real world works in messiness, right? Things coming in and out of order and all this. So I think this is brilliant.
Thanks, Dan. But definitely, I think a lot of data collection efforts, if you think about it, about the real world. Even if you think about something like server monitoring, server performance monitoring, log monitoring, and the like, we are thinking here about the hardware, and the hardware is about a device which may malfunction. It's the physics that comes in, and the fact that it may break, and it's about things like overheating and failures and so on. So a lot of these efforts about data that concerns physical things done by physical entities, either machines or, in some cases, humans, if we talk about consumer behavior. So it's kind of the natural way event streams behave, and indeed working with IoT data, the kind that we were working first, made us ready for certain complexities of data when we're talking about anomaly detection, alerting with out of order data, with data that has elements of both time series and geospatial elements. So we need to prepare for all of the complexities here of graph type and analysis, iterative graph algorithms, and so on. And we found that, in fact, if you take something like an iterative graph algorithm, remarkably few of the current solutions, I'd say none that's cloud agnostic, is prepared to handle this type of approach, to be able to have an algorithm which works until convergence, for example, or to optimize, to apply rules in a given order in a loop, etc. So there were things that were very much missing from existing frameworks, which we resolved in Pathway. And we found ourselves being a bridge that allows to conveniently express in Python the different ways of aggregating, harmonizing data, enriching it, and creating data pipelines that take data from different sources and add value to the data, in the sense that add structure and add extra information to the data to be able to use it downstream in business intelligence and analytics.
Yeah, that was one interesting thing when we talked before that I thought was cool was the same Python scripts that I write for data streaming analytics can be used in batch as well, because you guys kind of span you connect the two together very well. So I can run my real time analytics and then also go and do even more deep learning or deep analytics on things that have happened in the past as well without having to rewrite everything. I think that's actually a huge benefit to a lot of data scientists and data engineers.
Indeed, the amount of history that can be taken into account is much larger. Basically, whatever fits in the machines that are running the computation can be included, and this is a big difference from let's say the lightweight stream processors, which just take a little state and handle that. Actually, from what we see from our users, there are many problems with streaming systems that are related to usability, to being able to conveniently work with a streaming system in a normal development environment that data scientists are used to. For example, to rerun in a repetitive way a given data source, make sure the results are the same every time, to make sure to be able to simulate the impact of different changes to let's say machine learning algorithms to models, and see the outcome. And the idea of simulation means that actually when you're doing a simulation, you are rerunning a data stream, you're doing something a bit more batch-like in a way, because you have all the data batched, you just replay it in
Yeah,
the
all the
stream.
data sitting there already curated and in the right tables and everything, right?
Yeah. So this batch experience to designing and modeling streaming systems is something that we see as important for the future for real-time space in general, and the feature we're happy to bring with Pathway.
This has been great, Adrian. If people want to find out more about Pathway and about the products that you guys offer specifically around time series data, logistics data, and data streaming, this weird space in between data streaming and batch, where do they go to find out more information?
You'll find us at pathway.com. All the developer information is there, content, numerous examples all across verticals, from server log monitoring, anomaly detection in different use cases, to doing things like sentiment analysis on a social network, Twitter sentiment analysis and the like. So you'll find all the examples there on our GitHub repos. Don't hesitate to reach out to us on Discord anytime, Discord GG/Pathway. Happy to discuss and learn about use cases where you might find Pathway useful as well. We see numerous ones across multiple verticals, not just logistics, real-time financial data, data coming from actual operations of engines and vehicles, and all sorts of fascinating data sources. So happy to learn if we can help.
Well, Adrian, it's been a pleasure having you on the show today. Thanks again, and hopefully we'll talk again in the future.
My pleasure entirely, Darren. Thank you so much for having me.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and do something wonderful.